So the first thing we need to talk about is the definition of a function. And to begin to talk about a function, we first have to talk about a relation. All a relation is a correspondence between objects in two sets. In the picture that I have down here below, I'm thinking of the two sets as being denoted by these two different circles here. One contains apple, strawberry, lemon. The other shows red, green, and yellow. And the way we're kind of thinking about this is one set consists of some fruit or berries, and the second one is the corresponding color. So all a function is a rule that assigns to each element from one set exactly one element from the other. So we have to go to each one of these items here, apple, strawberry, and lemon, and make sure that it corresponds to only one element from the other set. So let's think, does this relation represent a function? Well, since the input apple corresponds to red and green, this relation is not a function. In other words, there's an input that corresponds to more than one output. Apple here goes with red and green. And that makes sense because we have both red apples and green apples. So this isn't really a function. So here's another example, except now instead of talking about apples and colors, we're just going to use numbers. That's what you're used to working with. So this first set here is going to be our inputs, and the second set, the red one over here, is going to be outputs. And so really what we're talking about is a function that's represented by a bubble diagram. It connects the inputs with the outputs, or the independent variable, which matches up with inputs, with the dependent variable. So to check to see if this rule is a function, and I've called this rule G, let's look at each one of the inputs. We need to look at the 2, the 4, and the 6, and make sure that it matches up, each one of those numbers matches up with only one output. So to check that, let's go ahead and look at them. So first of all, 2 matches up with 3. So an input of 2 matches up with an output of 3. That's only one output with that input, so that's okay. 4 matches up with 5. And 6 matches up with 7. So each one of those inputs corresponds to exactly one output. So this relation is also a function. So we would say that G is a function in this case. Now, another way to look at a function is to look at a table. Here we still have inputs and outputs, and in a table, usually our first column here corresponds to the input, and the second column corresponds to the output. If it's different from that, you're going to be told something to indicate that. So our independent variable here is the persons, and below we see individual persons, Greg, Sarah, Ron, and Tia. And the dependent variable is the years, and the values of the dependent variable are 18, 19, 18, and 29. So in order for us to check to see if this is a function, we have to figure out if each person corresponds to exactly one age. We have Greg corresponding to 18. So if we had the bubble diagram, there would have been an arrow between these. Sarah corresponds to 19. Ron corresponds to 18. And Tia corresponds to 29. So each one of those people corresponds to only one age. Now, sometimes people get worried because they see up here Greg's 18 and Ron's also 18. But what would be bad is if Greg was 18 and also 21 because he was carrying a fake ID. That would not be a function. So there's no problem if two people match up with the same age, Greg 18, Ron 18. So this, in fact, is a function. Now, a third way of looking at a function is to actually use a graph. And a graph is a way of visualizing many inputs and outputs. Our inputs are usually down along the horizontal axis, and our outputs are along the vertical axis. So when I see this point up here of 1, 3, that means that x equals 1 corresponds to y equals 3. And so our input of 1 corresponds to an output of 3. Now, do you see any other outputs that correspond to x equals 1? So if I look up and down here, I only see one place where I'm touching the graph. So that means along that vertical line passing through x equals 1, y equals 3, the only output is right here. This is true for all values of x. So if I went over here to -1, I'd see that also corresponds to 3. Well, that's no problem. As long as -1 corresponds only to 3 and nothing else, then this is going to be a function.